Okay. The next person asked me about independent and mutually exclusive. So I'm going to look at this problem here. And I'd like for you again, if you would, as a classwork, if you would copy this down. There's a problem, and there's going to be 3 questions that go with it. So the problem says at the top there were 2 choices in the lunch line, either chicken or vegetables. And so we've made a two-way table of males and females and whether they chose chicken or vegetables. Now they had to choose one or the other, so they could either choose chicken or vegetables. They couldn't get both. So they in the lunch line they had 2 options, 2 different ways that they could pick their meal. So I'm going to give you a second if you'll go ahead and write down this table. And I'll actually give you a chance to answer these 3, A, B, and C. A says to name 2 mutually exclusive events. B says what's the probability of choosing chicken. And then C says what's the probability of choosing chicken given that you are female. Okay. Now, 2 mutually exclusive events means 2 things that cannot happen at the same time. So in this problem, that is choosing chicken and vegetables. So if you're a person in this problem, you cannot choose chicken and vegetables. You can only choose one or the other. So they are actually mutually exclusive in the problem because it says there were 2 choices in the lunch line, chicken or vegetables. So you had to choose one. So those are mutually exclusive, meaning they don't occur at the same time. They had to pick one of them. They were not able to pick both. Okay, B, the probability of choosing chicken. So let's look at chicken. There's 85 that choose chicken out of the 195 total people. So 85 out of 195 choose chicken. So the probability of choosing chicken is 0.436. Alright. C, the probability of choosing chicken given that they are female. So again, we're only looking at the female row. That's 35 out of 105. Given is always your denominator, so given that they are female means we're only looking at the females. So there's a 0.333 chance of choosing chicken. Now, D, are female and chooses chicken independent. So here's what we're looking at. When we look at the whole group, over 43% choose chicken. When we look at just females, only 33% choose chicken. So are they independent? No, because the females are different from the entire group. So if we look at the total number of people, males and females all together, we see that over 43% choose chicken. If the probability of females was also at 43%, then we could say that they're independent. But since the females are less likely to choose chicken and these 2 numbers are different, then no, they are not independent. And the simple reason is because 0.436 does not equal 0.333. So what I'm saying is the proportion of people who choose chicken and the proportion of females who choose chicken is not the same. Okay, number 5. The last thing that I got on a sticky note somebody wanted to see, actually more than one person, a group of you wanted to see the different formulas and how to solve them. So I am giving you a Venn diagram problem. If you would copy this down, this is your last one before the test. You see 50% of people like carrots, and 30% of people like peas, and 15% like both. We're going to make A, the first circle, equal the people that like carrots, and B equal the people who like peas. Again, 50% like carrots, 30% like peas, 15% like both. And I need you to answer A, B, C, D, and E. And so this is working on the notation and the Venn diagram. So I will give you just a few minutes here. Let me give you a minute to try that on your own. Okay, so when we are looking at a Venn diagram, the first thing we want to do is start with the both. So 0.15 or 15% like both. We know that 50% like carrots, so this will have to be 0.35 to make that circle 50%. And 30% like peas, so this will have to also be 0.15 to make that circle 30%. If we add up those three numbers, we get 0.65, which means we're still missing 0.35, and that's how many people do not like peas or carrots. Okay, so question A. This is the probability of A and B. Remember, N stands for intersection. Intersection is in the middle. Okay, so that's 0.15, because that's the part in the middle right here. Okay, B says the probability of A or B. So that means one or the other happens. Could they both happen? Sure, but at least one or the other happens. So to get that, you're adding these together, and you get 0.65. Now, you could also have said, again, you could have also said 50 plus 30 minus both. Okay, so 50 plus 30 is 80, minus both is 65, or you can just say let's add these together. C, the probability of getting A and not getting B. So just A and not B, that's right here, that's 0.35. That's what this stands for, probability of getting A and not getting B. So it's not in the B circle, but it is in A. That's 0.35. D is the probability of not getting A and getting B. So we don't get in the A circle, but we do get in the B circle. That's 0.15. And E, the very last one, is the probability of not getting A and not getting C, or B, excuse me. So it's not in either circle. So it's this number out here, which is also 0.35. And those are the questions that they can ask you with the formulas and with a Venn diagram.